everybody. Welcome to OpenCV Weekly Webinar. And today we have with us Nisheeth Lahoti, who is the founder of Rephrase.ai. This is a company that recently created a very widely successful ad for Cadbury, where they took a celebrity, a superstar in India. His name is Shah Rukh Khan. And Shah Rukh Khan is like the Tom Cruise of India. And they made these special ads for individual local shops. So Shah Rukh Khan was actually speaking out the names of these local stores during Diwali, during the ad. So the ad would feature the local store's name. And this is just mind-blowing how popular this ad campaign was and how successful the AI behind it was. So we will learn how this was actually produced, the details, the technical details around that. Nisheeth, welcome to the show.
Hi, Satya. Hello. All right. So
we will come back to you for your introduction. Let me just quickly go over. I'll introduce Phil also for people who do not know. Phil is the content manager at OpenCV. He's responsible for putting the show together. Welcome, Phil.
Yeah, as Satya likes to say, if something goes wrong, it's probably my fault. Welcome, everybody, to another episode of OpenCV Weekly Webinar. Thank you so much for joining us again this Thursday morning. Got some beautiful golden sunshine and blue skies here in San Francisco, California. If this is the first time you're joining us, we do a couple of things every single week. One of those is a giveaway to one lucky winner. We'll ask a trivia question at the end of the webinar here, and the first person to answer it correctly will win a free OpenCV course from OpenCV Courses, where you can learn computer vision from the experts. We'll also be doing Q&A from you in the audience here, so please use the Zoom Q&A button at the bottom of your screen to ask your question at any time during the webinar, and we'll do our best to answer as many as we can.
Yeah, I'll sweeten the deal. If you, the person who receives, instead of doing the course, one course, what we will do is you will receive two courses, two copies of the same course, so that you can gift one to your friend. It's a holiday season, so you can gift one to your friend, and both of you can take the course together. So that's what we will give away. Now, back to Nisheeth. Let's learn a little bit about your background first, and then we will jump into the problem you have solved. And from not just a technical point of view, but also from an entertainment point of view, it's a big market that you're addressing. It's going to be really exciting. So let's start with your introduction, some background, how you got started, etc.
Yeah. Hi, everyone. I'm Nisheeth Lahoti. I did my undergrad, completed my undergrad from IIT Bombay in 2015, worked in Google about a year later, started the company Rephrase.ai in 2018, where we initially set out with a goal of with the very initial goal of dubbing, where we could make dubbed movies look much more realistic by making the actors' lips match in the dubbed version, match the audio in the dubbed version. So here's how it all started. Ever since college, I had wanted to create tools that could take in text and make realistic movies out of it. By 2017 or so, deep learning and image processing and all of this there were these big advances in computer vision. So we thought, okay, this would be a good point to get into it. Start by solving some relatively simple problem where at least you're creating videos, you're legitimately generating new videos of real people, and then work backwards on different parts and generalize it to more and more settings where the people are then maybe moving around, maybe they have other objects, maybe they're in complex environments and whatnot. It would give us that entry point into videos. So that's how Rephrase was started, with a vision of, we'll take an actor saying something, we'll take the dubbed audio, we'll convert the actor's lip movements so that it seems visually that they are actually speaking that dubbed audio.
Right.
That was the goal back when we started. Yeah.
Yeah, in fact, when we, when I was a kid or a teenager rather, we used to have many English movies dubbed to Hindi, right? They would, because I mean, India has more than 1 billion people, right? And many of them do not understand English, right? At least in the rural areas, people may not understand English, not the English. They may be able to read English, they may be able to write English, but they will not understand English when it is played in a movie, right? So dubbing really helps. So you have the actors speaking in Hindi, right? But you can clearly tell they're not speaking, right? It's almost, it's almost like, oh, you're saying over the actor. So it looked funny, but those were still very popular. And I remember
I grew up watching Godzilla movies that did the same thing. Shout out to Sandy Frank for the horrible dubbing jobs they did in the 60s.
The funny thing was that the names of the movies would be so ridiculously over the top. I can't remember an example right now, but when they converted the name of an English movie to Hindi, the names would be so ridiculous. I can't unfortunately remember one example, but that's something.
Yeah,
I remember.
often they'll like describe something that happened in the movie instead of like having like the regular movie title just kind of translated. It's
right.
Definitely interesting. The same thing with Italian movies in the 70s, like a lot of the westerns, they were in English but also in Italian, and yeah.
Oh yeah, and even direct literal translations of movie titles sound very ridiculous in one language because they're literal translations of phrases that would have sounded natural in a different language.
Right.
Absolutely.
So, yeah, it's all around a mess the way it worked. But yeah, that one thing was particularly jarring about all these dubbed movies, that people speak and the audio is something completely different, and you still you aren't ever entirely able to entirely get into it, but you still watch it because, well, that's the best option. If you want to watch Marvel movies and you don't understand English, that's the best you can do. But sure. Anyway, we, over the course of doing this, we realized that the tech that we had could in fact be deployed with much higher impact at other places as well, in particular in marketing, in reach outs, and in L&D. So I want to talk a little bit about, actually, you know what, before getting into the marketing use case, I think it's just better if I show you the video developed by Cadbury for a campaign that we did this Diwali with Shah Rukh Khan, the one that Satya was talking about.
So just so people have some context, Diwali is like the Christmas in India. It is the biggest festival. In many places, it is the biggest festival. And Shah Rukh Khan is like like Tom Cruise in India, except that because of population of India, maybe 3 times more people know about Shah Rukh Khan than Tom Cruise.
Got to be one of the world's most famous people, if not the most famous, right?
Yeah. One of the most famous people definitely in the top 10, right? So let's go over the ad.
Let's watch the video. It's got nothing to do with dubbing. It's got everything to do with changing people's voice and lips in the facial movement.
Excellent.
Here you go.
For people who are watching on LinkedIn and they want to ask questions, unfortunately, we do not have.
Okay. Can you all see that there?
We are unable to answer you, but on the Zoom, people can ask questions.
Big businesses and brands that suffered during the pandemic found their way back, but the smaller stores still suffer.
This lockdown has been a real tough phase of my life. I mean, I have seen bad days, but this was the worst.
Last year, we helped small businesses through Diwali. So this year, we decided to bring it back. Presenting not just a Cadbury ad. This Diwali, we helped hundreds of small businesses by making India's biggest brand ambassador be their brand ambassador.
इस दिवाली आप भी ना अपने पास वाले फैशन नोवा एम्पोरियम से ही कपड़ों की शॉपिंग करना और फिर एम्पायर फुटवेयर नाम तो सुना होगा अपना स्टाइलिश चश्मा बगल वाले हेवन आई ऑप्टिशियन से ही लेना सिद्धि विनायक इलेक्ट्रॉनिक्स से लेटेस्ट स्मार्टफोन खरीदकर धमाकेदार सेल्फी पोस्ट करना
क्या कर रहे हो मीठा लाए कि नहीं
लाया हो ना यार, अपने पास वाले रोशन किराना से। आप भी अपना मीठा वहीं से लेना।
We used machine learning to recreate Shah Rukh Khan's face and voice to take the local store names in the ads.
इस दिवाली आप भी ना अपने पास वाले चॉइस ऑफ फैशन से ही कपड़ों की शॉपिंग करना। पास वाले आजकल फैशन से ही, रॉयल फैशन से ही, एनके क्लॉथ्स से ही, पास वाले लक्ष्मी कलेक्शन से ही कपड़ों की शॉपिंग करना। इस दिवाली आप भी ना अपने पास।
Different versions of the same ad with local store names were targeted as per the PIN code of the viewer, showing them only the nearby stores. But it is impossible to cover all the stores. So we gave the power to the people to create their own version of not just a Cadbury ad. Any small business owner could promote their stores through their own social media networks like WhatsApp forwards and other social media pages.
हमारे आसपास की जो दुकानें हैं, उनकी दिवाली भी तो मीठी होनी चाहिए।
Cadbury celebrations, not just a Cadbury ad.
All right. That was
Wow,
really
yeah.
cool, man. Great summary of the video as well. I love the pullback where it shows, 100.
Yeah.
It's very neat.
So Phil, I will use you as a proxy. Was everything clear? You were able to tell what's going on, right?
Oh yeah, definitely.
Okay, great. Yeah.
And I barely speak English, so.
Yeah. So for everybody else, the sharing, because of the sharing, the video might have been a little jerky and clippy, but I guess it's a continuous thing. Shah Rukh Khan actually seems like he's actually speaking your store's name, right? So that's what we do in a nutshell. We can take somebody's video and change a part of it or generate new clips with the same background, the same location and everything, in which they're speaking something else. And we match both their voice and their facial movements, right? So I'll jump into how we actually do it. A few caveats here. Voice cloning is not something that we actually started with. We had initially decided to, take a bet on other companies doing it, that we'll partner with other people for voice cloning. In a lot of cases, they do actually work pretty well, but in some cases, it left something to be desired because, we don't have a very standard use case where we want to make people speak English and we don't have sufficient amount of data from everybody. So we also developed some version of it in-house, and that's what we used largely for the Shah Rukh campaign.
Right.
So
Nisheeth, before we move forward, I think people would already be having this thing, this question in their mind, whether this is deep fakes, and if not, are there any, can it be used for nefarious purposes? What are you doing to make sure that it is not used in a bad way, right? If you could address that, we'll get that question out of the way first.
Sure. So the two questions on what differentiates this from deepfakes and how do we make sure that this is not used for nefarious purposes are related. Deepfakes, as very typically understood, involves taking one person's video and converting their face to somebody else's. So, if you have my video in which I'm saying something, I could swap my face with Satya's or Phil's and you'd feel like they're saying the same things.
Right.
What we do is not that. We do not change one person's face to somebody else's. We make the same face speak something else.
Yeah.
It's called facial reenactment. And to make sure to prevent abuses, we have two guardrails. One is that we do not clone people's faces without their consent. If we are creating any video, if we are creating any model of somebody, that person knows that his or her model is being created, and we take the person's consent.
Yeah.
That is important to us. And secondly, for cases like this one, where anybody can honestly make Shah Rukh Khan speak a lot of different things, we have safeguards in place. We have blacklisting systems for every request that we get. Ultimately, at some level, it is passed through some check. It's passed through a whitelisting filter where, this is actually a legitimate name. This can work. Otherwise, we don't create the videos.
Right.
It's not a free for all. It's not open for the public to create anything that they want to without vetting.
Right.
on our end.
Right. So the whitelisting is that you have obviously all the whitelisting mechanisms, and if it fails whitelisting, does it go to a real human for them to verify that, oh, they had not accidentally blacklisted some name? For example, at one time, Facebook would not allow my username. If you look at my last name, it has the word lick in it, and so it would not allow that username. It was such a pain because I had to. We were trying to run some Facebook ads or something like that, and it would not let my normal email, and I had to I had to come up with something else.
And now the CEO's
so not Facebook, right? Yeah, but okay. We actually do check in a lot of cases that the blacklisting, it goes to a human in most cases. Yeah. Honestly, most of the categories just hit one of our pre-blacklisted or pre-whitelisted names, which we develop over time. Right. So we don't need to do this for every video actually, because mostly it'll hit that. Yeah. But for the ones we haven't seen before, it does go to a human being. Okay. Although even there, we are biased towards rejecting rather than accepting. If something is unsure, right, we tend to err on the side of rejecting, because you really, really do not want people to create viral videos of celebs saying cuss words or whatever. Right.
Accidentally create some international incident, some politician or something.
Yeah, that could just be a disaster. Cloning politicians generally might be a general disaster. Best to stay away from that sort of a thing. Right. Right. So
go ahead and reshare your screen as well.
Yeah, sure. I'll do that. Just a second. So I'll actually get into how the thing is done. But yes, before that, a few caveats. I'll not go into details of voice cloning. And I'll describe a video creation pipeline that's a slightly older version of the pipeline that we use now. Right. Sure. So the problem setup is this.
One point in production, right?
Yeah, this was the real version in production. It's not as of this moment, but it's real production version of the pipeline on how these videos are created. This is also so here's the setup. We record somebody for let's say some X duration of time, so that the machine learning models can learn how they speak, their voice, face, everything. If you want to train models from scratch, often you need to record a lot of data of somebody. But in our case, what we can do is if we have just a lot of data for one person, that's enough. We can use that, and significantly smaller amounts of data of other people, and convert this one person's facial movements, which our network can now easily predict, into these other people's. Mm-hmm. Right. So here's how the whole thing works.
How much data usually? So suppose for the Shah Rukh Khan video, how much audio did he record before it started becoming reliable? 10 minutes of audio, or how much?
15-ish minutes of data for Shah Rukh Khan. Yeah. But honestly, 15 minutes is something that we just record to be on the safe side of. The whole approach mentioned here will give you somewhat decent results for as little as 2 minutes. Right. It's just that the errors start going down as the data increases more and more, even with the retargeting approach. For the one person that I said that for whom we just have a lot of data, we could record as much as an hour, 2 hours, 3 hours of data, because that's in our control. We can have one of our own models do it.
And what do you guys ask them to read? Some regular text, or is it something specific you want them to say?
Yeah, like the quick brown fox jumps over the lazy red dog, or whatnot, which is the classic way you test typography.
We do have specific scripts that we share, but honestly, more or less any script can actually work as long as we have an accurate transcript.
Right. Got it.
Right. Got it. It's right. So for example, if you just want to have all the letters, all the sounds within a very, very short segment, 2 seconds, 5 seconds, 10 seconds, you'll need one of those sentences. The example that Phil gave, that, the quick brown fox jumps over the lazy dog. It will contain everything from A to Z.
Yeah.
But if you actually have a paragraph that's, I don't know, that's like, if you actually have an essay that is 4 or 5 pages long, you don't really need to make sure that it contains any special sentences just so that it can contain all the letters. It will naturally tend to do it. Right. So just because of that principle, almost any script actually goes. Yeah. So here's the setup. You have N people. They could be speaking with different texts, different accents, everything. For each person, you have some amount of data. You have a lot more data for, let's say, P1. And now you want to train models that can create these videos of all sorts of different people. So this is the overall structure of the pipeline. We convert text to audio using the voice cloning text to speech mechanisms. We have a module called, okay, now first, if you want to predict the entire shape of the face using just the audio features alone, that might get overwhelming for the network to do. So what we do is have a lower dimensional reduced representation, a small 20-ish dimensional vector that can encode what your facial shape is at that point. Everything from, how much your lip is open, how much the extent to which your teeth are visible, the extent to which it's wide, it's open like this, everything.
Right.
So that's all contained in a small condensed vector.
Right.
We have this module audio to face, which takes in audio and converts it to this 20-dimensional representation for each frame of the video for P1. Right. So P1 was again the actor for whom we had a lot of data.
Yeah.
So on every frame of, let's say you want to create a 30 FPS video.
Yeah.
So for 30 times a second, you'll predict what the face shape should be based on the audio. Then we have a module called retargeting that takes in this lower mouth representation, dense representation of P1 and converts it to a representation for PN, the nth person.
Right.
Right. So audio to face network is just trained once for P1. Retargeting is trained separately for every individual actor.
Right. And just so that people are not lost what this representation could be, we can say that this representation is, you could be doing facial landmark detection on the lips, right? So you could be having the contour of the lips, that's the geometry of the lip, and then you could have color information about the lip. And that's what could be the representation, right? You'll come to it in the next few slides. But just to give people context, that it is the geometry as well as the color information, but it is encoded in a small vector. It's a 20-dimensional vector instead of, like a lip region could be 256 by 256, which is a pretty large number, 198, whatever it is, right? So it's a much lower dimensional representation, but it encodes important information about the structure as well as the color of the lip region. Is that roughly?
That's pretty accurate. Thanks, Satya. Okay. So after getting this representation for every frame, we have a neural rendering module that converts it to an actual face, an entire actual face. This is also a module that's trained separately for each individual person. And this finally, after having created these bunch of frames, we now post-process the video, add any background music, background images, background visuals, any cropping, everything to be done, and create the final video out of it.
Right. And this neural rendering, can we think of it as some sort of a super resolution, that you have the structure and color information at a lower resolution, and then this neural rendering is basically doing super resolution? Is that roughly the right way to think about it?
Not entirely. What we are in fact doing is taking a 20-dimensional vector and converting it to a full-fledged facial frame. The 20-dimensional vector and the background information, everything apart from this area, the lower face area, the eyes, the head position, the background and everything. We take this 20-dimensional vector and use it to fill in all this from scratch. It's more of an in-painting sort of a thing than kind of sort of in-painting, though not exactly. Right. So here's how the audio to face network works. We take in the audio, We have feature extractors on top. The feature extractors can be different things. They can be phonemes, they can be MFCC features, they can be autocorrelations, bunch of different audio features out there. Again, 30 times a second, we'll extract these features. We'll have a trainable deep network that will create these 20-dimensional features as an output. And here's what these 20-dimensional features actually are. So those of you who are aware of active appearance models would find this very familiar. It's largely based on that concept. That's a traditional technique, not related to deep learning. So what active appearance model technique was that they detect a bunch of landmarks on the face. They morph these landmarks into, okay, they'll first take, if you want to create an active appearance model, you first take a PCA of all these detected landmarks and have one vector from there. You call it the shape vector. Then you morph this image into a very standardized position where all landmarks are at a fixed position. In this standardized position image, you take all the colors, the individual pixel value in the colors. You take a PCA of those, you call it the appearance vector. And then you concatenate the shape vector and the appearance vector, and you have a full-blown vector for that represents what the mouth shape there, what the facial position expression there was. We use a slight modification of the AM approach. The main differences are, instead of just predicting a bunch of landmarks, we predict a whole 3D mesh so that its deformations are very accurate. If you just predict a bunch of 2D landmarks, then if I move my head from left side to right, if I just shake my head this way, what happens is that my appearance unnecessarily changes when it shouldn't. Only my shape should have changed.
Yeah.
Even the shape shouldn't have changed, only the orientation should have changed. So we train 3D models so that it's robust to that effect. You can shake your head without any problem. Yeah, but that's the thing. We create a very dense mesh of vertices, several tens of thousands of vertices on the face.
Oh.
We take PCA of their positions, get the shape vector, we take the color at each vertex, we get an appearance vector, we concatenate them. It gives us an overall 20-dimensional vector. Right. This is so far pretty classical. Nothing except the mesh detection, mesh creation thing here is a DL thing.
Right. And for people who may be wondering, what does this mesh look like? You can see a lower resolution version of this mesh on MediaPipe. So if you do MediaPipe face mesh, you will see what kind of mesh we are talking about there, right?
I'll go ahead and drop the link to that in the chat.
Yeah. So Nisheeth, is it some mesh like that? Or maybe a denser version of that?
Yeah, right. It's a pretty standard dense mesh. You'd get it if you just search for a face mesh. That'll be a good idea. It's very, very densely spaced. Right. So we get these representations. We train the audio to face network to predict these representations based on the audio data alone. This is done using a very normal gradient descent based training with a bunch of losses, a reconstruction loss, a velocity loss, something that will make sure that you have temporal coherence. From one frame to the next, your representation isn't jumping around wildly, and a discriminator that will make sure that overall larger sequences are looking realistic. Right. Now, after that, what we do is train a network from the PCA parameters of one person, this dense representation of one person, to the dense representation of somebody else. This is done using something called invertible neural networks. Invertible neural networks are this interesting class of things which can predict a mapping from A to B and also predict a mapping from B to A. The reason it's better to train a network that can predict it both ways is that this way you preserve the diversity and the variance in the facial shapes. If you just train it from A to B, you often tend to lose some of the variance in the process. All right. Mm-hmm. Satya, by the way, how much time do we have remaining?
We have about 27 minutes.
Yeah, sure.
Yeah.
So this network is something that, right, we'll get it from audio to face. We'll predict the audio to face network. We take in the original video of somebody saying, here's how the retargeting network is actually trained, right? Say I am P1 and Satya is P2. You have a 40-minute video, you have a 40-minute or 1 hour or 2 hours or whatever video of me saying something on which you have learned a very efficient audio to face representation. You have a, let's say 5 minutes video of Satya saying something. You want to actually be able to learn how Satya will speak. You want to be able to learn a network that will convert from my facial points to Satya's. So the way we'll do it is we'll take in Satya's audio and pass that audio through the audio to face network that predicts the key points, the PCA parameters of me saying that.
Got it. Yeah.
So you get what my parameters, what my face would have looked like when speaking out that particular audio, right? You then, now you have a one-to-one mapping, right? The reason you could have trained, you can also go with approaches where you directly train networks that move from one to the other, right? Except that often when people speak, the audio and the lips don't have exact frame to frame correspondence. It tends to vary a little bit here or there. So you can align them using techniques like dynamic time warping, right? And you can have these invertible networks that predict things.
Is that affected at all by the
so
frame rate?
Not really, because in my network, when you made any prediction, you make predictions independently for each frame. You take in a chunk of audio and you predict the lip shape at one particular frame. So suppose my video was at 60 FPS, but Satya's was at 25. That's still okay because you'll make predictions for me at only 25 frames per second, right? So you'll have a 25 sequence of length 25 of my key points.
Is it more likely to be accurate with a higher frame rate, I guess, is my other question?
It's certainly more likely to be accurate with a higher frame rate. So let's put it this way. If you have a 5-minute video with a frame rate of 60 is somewhere between, in terms of how good it is for us, it's somewhere between a 5 minutes video at 30 FPS and a 10 minutes video at 30 FPS. It's certainly better than a 5-minute 30 FPS video because you have more frames, you have more data to train on. It's certainly not as good as a 10 minutes 30 FPS video because at 5 minutes the data is a little more correlated.
Right. So there's a little bit art to the science here, is what you're saying.
Yeah.
So there is I like your approach. I mean, there could have been a naive and not good approach where you say that, oh, I want both the original actor and both P1 and P2 to say the same sentence, right? And then you do dynamic time warping to bring them in alignment and do all kinds of messy things, right? But that could have been an approach, but I don't like that approach. I like your approach better, where you're not making them say the same word. You have trained a network on this main person, P1, and made them say this, what this new person is saying. That's much, much better. And that does not require you to select the same phrase. So that's clever. I like that.
Yeah. Yeah, we actually started with the approach that you mentioned, Satya, and then
you did
realized over time that, okay, we could just do this and avoid all the hassle of people saying the exact same thing.
Right, because that other approach seems without knowing what you tried, we have not gone over these slides before. So this is what I was predicting that you would have done before we had, you started explaining this.
They say great minds think alike.
Yeah, but experience, because Nisheeth has more experience now in this particular domain. He comes up with better ideas.
Right. Over time, you just realize that, okay, we could just have done this instead.
Right.
And saved hassle for everybody. Right. So then here's how the neural rendering thing works. We actually had different versions for this pipeline too. This is the very initial version pipeline that we had, where we just took training face images, took these 20-dimensional features at every frame, and did some sort of candidate frame selection. It's not exactly candidate frame selection. We sort of order the frames based on how close they are to the representation that we want. We take the bunch of closed frames and kind of synthesize an entire face using them. Using traditional techniques, we get a very low res kind of a face. We pass it through a neural network to make it very high res and make the teeth and everything very sharp. Okay, so this was an older version of the module. Later, we just developed a network to directly go from these 20-dimensional features, render them back, because of course we have created them using a very traditional technique.
Yeah.
Take those rendered images and predict the whole thing from the rendered images won't contain everything. They won't contain anything outside the face, for example. They won't contain whatever is there in your neck, just in these background areas and everything. So a neural network can both fill in all those details that are missing in this face and do a super resolution on the sorts of features present inside the face.
Right.
Right.
How much time does it take to render this, let's say 1 minute video? You're actually not doing 1 minute because you're just replacing that little section, maybe 10 seconds or maybe even 30 seconds, right?
When we started, we probably needed something like 5 to 6 times the length of the actual video to be able to render it on a GPU.
Yeah.
At this point, we can do it in real time. We can render frames at something like 40 frames per second. Typical videos that we create at 25 to 30 frames per second. So it's something that we can do in real time at this point.
That's on a GPU.
On a GPU, that is right. On a CPU, this would be a nightmare.
Right. No, it's still very impressive. I mean, doing this thing in more than real time, it's really impressive.
Yeah. Right. Hello. Wait.
Lost your screen share there.
It's just stuck at my end entirely. I can't. Anyway, yeah, right. So, in fact, I was pretty much done. That is it. On top of this, we can create. On top of this, we are in the process of creating things like changing head movements of the person in real time. We actually have that technology in house, though it's not very useful in the particular Shah Rukh Khan related case that I talked about.
Yeah.
It is useful in other cases that we are targeting. So the Shah Rukh Khan example was just one where you take an entire video and you edit a very small excerpt of it. We can also create end-to-end videos. They can be used in learning, in online education, in corporate learning, people, the CEOs, CXOs addressing people in their company,
right.
Cases like that, where we create more long-form content. So there, even the head movements, eye blinks, everything needs to be somewhat realistic in sync with the audio.
Right.
And we are also in process of deploying that where, the head movements can change with time too. Like we have the technology there, it's not deployed yet.
Right. That's impressive. And now you also have, you did not talk about it, but you do have your voice synthesis module also right now.
Yep, that too. We, as I mentioned in the Shah Rukh Khan campaign, we actually synthesize the voice ourselves for the user-generated videos.
Yes, nice.
So
we have enough time for questions today.
Yeah, definitely. Thanks, Nisheeth, for being one of the first guests in like 3 months that actually was on time with your presentation. I don't know what to do now. No, so we'll take some questions from the audience here. Thank you again for the presentation. Sandeep would like to know what kind of infrastructure is used for this work. How many GPUs? What kinds? Are you using a service for this, or is it? Do you have your own hardware, etc.?
We just use the normal cloud providers. One T4 GPU is enough.
Just you have some examples of those cloud providers?
AWS, GCP, Azure, the standard ones.
Yeah. So in a startup world, you get $100,000 worth of credits from one, then you move on to the next one, 100,000, and you move on to the third one, and this way you are done for 3 years, and then you get acquired.
Right. Hopefully you get acquired before you run out of free stuff.
Yeah, we'll end up running out of the free stuff sooner, but yeah, it if nothing else, it gives you good experience with evaluating, how they work comparatively. And yeah, we've used all three by this point.
And do you guys did you have to use Kubernetes for scaling during these campaigns, or one GPU was enough?
So, oh no, one GPU is certainly not enough. One GPU, just to create one video at one particular time, you need an entire GPU plus 4 to 6 CPU cores associated with it.
Yeah.
So we did use scaling. Kubernetes, in its very typical use case, is targeted at the inbuilt assumptions are slightly different, where they assume that on a single node you'd be running many pods. In our case, that's not true at all. On one node we run one pod.
Right.
So we did use something like Kubernetes, but it's as good in our case as just calling the APIs directly of starting and stopping machines.
Got it. Okay.
Makes sense. Yeah, thanks for that. Dan Beavers would like to know about how long was the development process once you decided what you were going to do with this, like once you pivoted from your original intentions?
It was a very continuous thing. So it had taken us something like 5 to 6 months to develop a version initially where you could retarget from one person's face to another in a video where that person is looking straight. And then when we decided to pivot, we had to add some new tech to it because we wanted to predict the lip movements from audio rather than just predicting it from one person's shapes to another. And we also kind of rewrote a large part of the pipeline based on what we had learned in the 5 to 6 months. And so we pivoted in Feb 2019 and had a basic version of this thing running by April 2019 or so.
It's pretty quick, actually.
Since then, it's been a long, continuous process of improving the quality, improving the lip sync, making it work for more and more people, actually getting out there in the market, that sort of stuff.
Yeah, definitely got out
and
there
voice
on the
cloning, yeah.
Would you say that yours is the first company to use this in advertisements at this scale? Worldwide?
In advertisements at this scale, yes. There are other companies out there who have pretty similar tech who are also just coming up at this time. Hard to call anybody first in that, but yes, at advertisements in this scale, we're the first ones to do it.
Yeah, and there's also, smaller versions of this have existed for forever in broadcast media. My brother used to work in news, and they have a thing called a morph cut, which helps remove all the ums and uhs and stutters and all of these interviews on television. But it doesn't work great for when people are moving around a lot. If they're stationary and the camera's stationary, it works great. When you have actual complicated stuff like this, you need something like Rephrase.
Yeah, and there was also this Obama video which was created where Obama was made to say they did not do voice synthesis for that video. There was a voice actor who spoke in Obama's voice, but they did the lip morphing part. I think BuzzFeed or somebody.
There was a Tom Cruise one as well.
Okay.
Yeah.
Obama had actually become sort of so the entire research cottage industry around this, a lot of papers and a lot of people doing this had started to use Obama as sort of a benchmark for how to do this. He had become the standard, guinea pig of this whole industry, let's say.
That's funny.
Yeah.
Thanks for that. So we have another question here from Sandeep, who wants to know, because only the lip movement is replicated, does that mean that the expression stays the same, or can you actually change eyebrows and stuff too?
So in the celeb-based videos where we are just in the marketing videos, we're just editing parts and parcels of it. We don't want to change anything really, because if regardless of whether Shahrukh is saying hi Nisheeth or hi Satya, he'll probably have the same sort of expressions. In long form content, yes, we are we don't have that deployed yet, changing the eyebrows and everything, but we are actively working on it. We have the technology ready. We are in the process of actually deploying it out there.
Cool. Yeah, that'll be pretty interesting. And yeah, again, we were talking about this before the show. I'm just imagining Cameo just driving a dump truck full of money to your offices and dropping it off, you know. Rajat would like to know about your background. Did you do any online courses, or you talked briefly about what you did in school, but were there any other resources that you used that really helped educate you for this, pretty big task?
Please lie and say that you did our deep learning course. Just kidding. Just kidding.
You mean tell the truth and give us credit, Satya?
A bunch of online stuff here and there. It was miscellaneous. It was a bunch of papers. It was the deep learning book by Ian Goodfellow. It was the FastAI course. A whole bunch of things from assorted things from here and there. No particular online course or nothing formal as such.
So
I had some ML experience back in
FastAI, you said there?
Yeah, I had some ML experience back in college a little bit, but deep learning wasn't really a thing. TensorFlow came out the year I graduated, and I mean, it was a thing, but it was much more of a niche thing. I hadn't heard much of it. I wasn't aware of any frameworks, Cafe or whatever was around back then. So yeah, I had a decent background in linear algebra, and in I knew what neural networks were. I knew backpropagation and everything, how it worked. But actual deep learning frameworks, I just did a bunch of miscellaneous assorted courses, read a bunch of papers, implemented a bunch of things myself.
So Elon Musk says that 99% of machine learning is dot products.
Close, right? with dot products and ReLUs, you're probably up to 99.99.
Right.
That's seems to be the case.
Yeah, and just to add to that, people who are starting out and maybe thinking that it's really tough, but the fact that this whole deep learning revolution started literally 9 years back, right? In computer vision, at least. So the amount of literature you have to go, it's not like you're learning physics or something where you have to go through 200 years of research. Here, it's really small, really small. You can be very good at something in months. And Nisheeth is an example, but we also have from Fast.ai, Jeremy Howard taught himself this thing, right? He was not originally a machine learning researcher. He taught himself, and he's a leading figure now. So just people who are starting out, it is certainly possible to develop very good expertise if you commit to it in months, right? You don't need years and years. In months, you can have very good expertise.
Yeah, you don't have to go back to Copernicus or like the state of the art has only existed for about 9 years. So, Serge would like to know, have you used this for generating lyrics for songs in different voices?
Not really. We can't create pitch that accurately, so that wouldn't work.
So changing the pitch would be a difficulty for and holding maybe holding notes as well. It might be difficult to get clean.
Right.
It's interesting.
So the audio technology isn't quite there yet. With videos, we could try, but we haven't. I mean, with videos, by videos, I mean, if you just take some singer saying something, I don't know, Ed Sheeran singing something, and try to have my face on top of it, sure, I guess I could try something like that. I just haven't yet.
Yeah, I see. I'm thinking I want to lip sync Mariah Carey doing like Christmas death metal. Serge would also like to know about accents. This was a really interesting question to me. Have you looked into, can you change people's accents? Have you looked into like changing the certain pronunciations? And if it's possible, how much data would you need to do that?
Interesting. Definitely sounds doable. There are tools. ASR technology is pretty good. You can have that ASR technology and you can create things in that accent on somebody. Yeah, it all sounds doable, honestly. Not that much more data. We haven't done it yet, but very, very doable for sure.
And it's also, the funny thing about accents is that when people who are from different backgrounds like myself, if I were to talk with Nisheeth, right, in person, just him and me, my accent would be very different. let me try it, right? It would be something like, "Hi Nisheeth, how are you doing?" Right? It is very different than saying, "Hi Nisheeth, how are you doing?" Right? So it changes accent based on who you're talking to, right? When I'm talking to you, my accent is different than when I'm talking to one of my Indian friends.
Yes, this is true for when I go visit friends or when I see friends. I'm from Michigan. It's, you know, a pretty identifiable accent. When I'm in Michigan, I have a much more Michigan accent. It's the A's are a lot longer, and yeah, it's an identified phenomenon for sure. We got time for one more question before our trivia here. Michael would like to know, how good are you at identifying fakes now, Nisheeth? Can you do you think you can reliably identify a faked video just by watching it now?
Honestly,
you have to have seen a ton.
Okay, honestly, I, along with every other deep learning researcher at the company, once gone through a stage where even real videos start looking fake. You know, I'd be looking at some movie and it's like, oh no, the lips don't quite match.
Yes.
That's just wrong. So so it's very possible to overfit.
Yeah, now your brain's overfitting.
Yeah, right. But I have some sense of it. I don't think I'd be a perfect predictor of it, but sure, I'd have a lot better sense than most people at, you know, really pointing out, okay, is the lip sync entirely right?
Like there's this joke that, you know, robots and humans will be very much alike in the future, and it's not just because humans, you know, robots are becoming more like humans. Humans are also becoming more like robots.
Yeah, I definitely, you know, I write so many words every week that sometimes certain words will just stop looking like actual words. I'm sure everyone has had this phenomenon happen where, like, I know that's how you spell the word teeth, but it just seems wrong to me right now, like in my brain. I'll do one more question here. Rajat would like to know, do you have plans for expanding this that you can talk about into US advertisements? Do you have any deals in the works that you can speak on?
No deals in the works that I can speak on, but we'll definitely expand into the US in the coming few quarters.
Cool. Yeah, thanks so much. So I guess we'll do our trivia question here. So if this is the first time you're joining us on OpenCV Weekly Webinar, we have a giveaway here. Satya is generous enough. We will be giving you two. Any OpenCV course, can they choose?
Any OpenCV course you choose. We have Computer Vision 1 for beginners. It's an introductory course, but digs deep into traditional computer vision, also goes into deep learning a little bit. But if you want a deep learning specifically, then it is deep learning with PyTorch. That's a very good course. So, but you can choose any course. I personally would recommend, you know, one of these two courses.
Awesome. Yeah, and so we'll be giving you two, so you can gift one to a friend or family member of yours this holiday season here, thanks to OpenCV courses. The way this works is I'm going to ask a trivia question that I've made up from the slides during the presentation today. You're going to answer that question as fast as you can in the LinkedIn chat window here. If you've won recently, please don't answer. We got to give other people a chance to win.
You meant Zoom chat window.
What did I say?
You said LinkedIn chat window.
Whoops, sorry. Well,
sorry.
we won't be doing it in the LinkedIn chat window because of the time shifting. It makes it hard. In the Zoom chat window here, please answer the question as quickly as you can, and the first person to answer it will win 2 copies of the OpenCV course of their choice. Get ready to answer now. Before retargeting in the presentation here, the audio went through an AI process to generate speech and face animation. What is the name of that package? Oh, they got this one already. I was on a streak. of stumping them, but they got us quick. The answer, the first one, looks like Rajat, Audio to Face was the name of the package. So congratulations. Please send one email to phil@opencv.org, and we'll make sure that you get your courses. So great. I think that's about it. Do you want to take us home, Satya?
Yeah, thank you so much, Nisheeth. It was a pleasure. You know, I really loved the technical talk that you gave. It was illuminating, and you know, the main thing is that it actually works in real world at scale. So that's it was a pleasure to talk to you. Thanks.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision from the experts at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.